Hey up everybody, welcome back to Yorkshire Fab Shop. Apologies, it's been a while, been quite busy recently, but back in it now, so we'll get some more content knocked out. Focus of this video today is I've accumulated some new stuff, some new exciting equipment. Can't wait to share it with you. First and foremost is, obviously the focus of this video is the milling machine that I've got and needs a bit of a TLC. Few pieces to supplement that, which we'll go through in just a minute, but sit down, grab a brew, and we're going to take you through the small task of refurbishing this bit of kit so that we can finally use it. Before we start wading too deeply into the world of milling machines, I thought we'd stop and quickly look at this. Those that know what they are will recognise this as a transwave phase converter. Those that don't know what it is, it's basically a magic box of tricks that turns your single phase out of the sockets into three-phase 415, so it'll run three-phase motors. Massive bank of capacitors in there, and obviously many magic things happen, and out it spits 415 volts. So there is a bit of wizardry at play, that it takes the third phase and recycles it, and background EMF, all these fancy words, and somehow it generates your three-phase. Anyway, big quality of life improvement this is, because now I can run three-phase motors. Now the great thing about this is it was actually cheaper, obviously second-hand, cheaper than the equivalently sized VFD. Now I did consider the VFD route, as a lot of us have done, and I kind of chose not to go down that route, first of all because of the cost, second of all because you need 3 or 4 depending on how many machines you've got. You don't get the plug and play that you get out of these. So if you've got a three-phase motor, put a 5-pin plug in it, shove it in, away you go. You haven't got no programming, there's no faffing about, no setting up. However, the big advantage of these is you don't get the soft start, you don't get the speed control and the various other delayed starts and sort of functions that you can get with the VFDs. So there is a bit of a drawback, but this will do all my three-phase equipment in one box, no problems. So just plug it in, away you go. What that does mean though is now I can run my equipment with three-phase. So lathe is a bit underpowered. I'm looking at getting a bigger motor for that. The milling machine, we've got a three-phase motor on that, and I've also got a three-phase drill now. So basically all my equipment in here is going three-phase. So without further ado, here she is. Probably not seen one of these before, and I hadn't until I came across it, but it is in fact a Woodhouse & Mitchell 369. So it's the same manufacturer as the lathe, and, as I like, proudly manufactured in Yorkshire. So what attracted me to this? Well, there were sort of 3 main caveats that came with purchasing a mill. Number 1, it had to be of a certain head height because I haven't got a lot of space where this is now. Number 2, it had to be very cheap because I had a limited budget. Number 3, it had to be single phase. Obviously at the time it had to be single phase, or had to be able to be converted to single phase through change of motor. Now clearly that's not a problem, and I am actually going 3-phase with it, but obviously at the time it was quite an important one. So overall, very happy. It was very cheap, it's not in bad condition, it's not a bad mill really. The only disadvantage is it's got a bit of a rubbish taper in the spindle nose. I really wanted an ISO 30 as a minimum. I wanted a machine with an ISO 40, something like Bridgeport copy, so an Ajax or an XYZ or Beaver, one of those, but I can't get it in because I've not got enough head height. So I had to compromise, and I've got a Morse Taper 3, which is not the end of the world, and yes, it's not the best, but there's plenty of tooling available, so we'll get by for what we need. It also hasn't got any power feed, which is a bit upsetting. But again, given that the price of the machine was so cheap and it's in relatively good condition, considering we can't have everything. So what I do want to do is talk through some of the main features of this and what makes this such a versatile machine and ideal for the home workshop. So if we take a closer look at the head then, we'll go through the reasons why this is really such a unique machine actually. First and foremost, it's got 4 axes of movement. Yes, it really has got 4 in this quite, alright, it's sizable, but quite compact head. So the first one we can see, and you can see with this, it's got a handle on both sides for the quill. So it's got quite a modest, but not bad, 4 inches of travel, but it's also got the fine feed, which is a nice little feature if you're doing some drilling, or rather than winding the table up because it's fixed for whatever reason, we can just do it on here. Second of all, if I grab the top, it nods through, well, depending on how much space you've got, it nods through kind of 180 degrees. So we could, for argument's sake, you could machine upside down. I don't know why you'd need to, but you could rotate that right round so that you were machining uphill. Yeah, I don't know why, but you can do. So that's 2 we've got there. Number 3 is this whole head will slide sort of backwards and forwards because there's a cylindrical arm that attaches it to this, obviously this mount on the back of the machine. So it'll slide in and out. So obviously you can set the head at a particular position for whatever reason, and obviously machine there, move the table. Number 4, if I grab this hand wheel at the back, we can tip the head side to side, and that will actually do a full rotation as well. So it'll do a full 180 degrees, which is quite impressive really. So you can have it in some really unusual positions. If you go on the website, the one that's got all the, obviously the lathe, milling machine, drill information on, there's some quite good pictures of this, and you can obviously draw the head right out. You can tip this at sort of 90 degrees, and the whole turret will rotate as well. So I suppose you could argue there's kind of 5 axes, but just there's 4 just on the head. So you can turn it and sort of mill back on yourself, which is a bit weird to explain, but have a look at the pictures because it's quite interesting really. And then where the motor is mounted, not quite sure why, but this has also got sort of 4 positions you can have it in as well. So I suppose if you needed to turn that because it were going to foul on a piece of work or the table or something, then you can turn that out of the way and obviously put it wherever you want. So overall then, pretty happy with the mill. There's a couple of areas where the table's been attacked with a cutter and obviously careless milling, but I don't mind too much because we can kind of live with that. Table wants a bit of a clean. It's got some surface rust on. I did try and protect this a little bit, but it's quite damp obviously in this country, so it does suffer with a little bit of corrosion. You can see I've put plenty of grease on all the slides, so they're all in reasonable condition. But yeah, as a machine, quite happy with it. So what have we got to do to recommission this then? Well, you saw just on the top there isn't a motor. When I bought it, there was a single phase motor on it and it did work. However, it was pretty poorly mounted. I'll just grab this bracket. So this was bolted to the top of the mill, and then the motor was mounted, a foot mounted motor was mounted on these bits of pigeon crap welded on brackets, and that was it really. I weren't happy with that really, to be honest, so I ended up taking the motor off, and just as it happens I used it for something else. When I got the 3-phase converter, it gave me the option of 3-phase. So what we need to do is, I've got a motor in mind for this. We basically need to attach it and get it working. So that's the plan today, is we're going to mount the motor, get it running, and just see if there's any other faults with it, because it does want a bit of a clean, but overall it's pretty good really. So then the challenge is we've got to get this motor onto that machine. So originally this motor came out of the factory with a 1 horsepower motor. I thought that was a bit underpowered. Famous last words, I know. But what I'm going to do is I'm going to upgrade it to a 2 horsepower. So this is a 1.5 kilowatt 3-phase 1400 RPM motor. So as far as the speed's concerned, speed's the same, but twice the power. So we shouldn't have any issues with the sort of the bigger, heftier cuts and the big fly cutters and stuff like that. We won't have any issues spinning that up. So that's good. We need to attach it to this by means of drilling, screwing, threading, tapping, whatever we need to do. We need to get that onto there, and then that will bolt straight onto the top of the motor, because this is the original motor mounting plate. Whether it's a motor casing or not, I don't know. If they were sort of combined into one, this is the motor casing and sort of the tensioning plate as well, because this slot here is used to tension the belt. So that's a fixed point. This spins about that point, and then obviously that moves the pulley away from the other one and puts tension on the belt. So that's the plan. Probably get a piece of plate that'll make up sort of a patch plate between there and there, so we can screw that through there and sort of spigot it on and make a nice job of it, really. So that's the plan. We're going to get some scrap and machine a plate probably and bolt that to that, and then that to the mill. Right, so with that machine now, I appreciate it's not the best machine job in the world. It was just a piece of scrap, obviously, and that's good enough for what we need to do. So we've machined this in a diameter to size, and we've machined that little step there to size, so that'll now fit snugly in there. And obviously that inside diameter will fit snugly onto there. So we've now got an aligned motor to the original motor casing, because I think that's what this was. And the axis of the original motor is now maintained, so that when we tighten this, it'll stay in the correct orientation on the milling machine. The only thing that's left to do now is to fix the motor to this old motor casing. The problem being that the inside diameter of this motor casing is bigger than the PCD of these 4 bolt holes on here. So what I'm probably going to have to do is open these holes up a little bit so that I'll be able to get a good fixing into this motor plate. I could get away probably with some smaller fasteners, but I don't want to go too small. I know it's not going to be doing a lot of work, but I don't want to go too small because I don't want it ripping itself off when I'm using it, especially if I've got a big cutter in there. So I'm probably going to get the desuter. I'll open these holes up a little bit, and then I'll be able to drill and tap through these 2 pieces and fix it all together. the motor now mounted to the top of the mill where it needs to be, we've run into a couple of small problems that won't be difficult to rectify, thankfully. You can just see here that the plate that I had machined, in hindsight, and I could actually throw it back in the lathe, to be honest. I ideally should have machined it down to the diameter of the motor, or even a bit smaller actually, because when I rotate this, so this is the tensioning method. You can see it's actually touching on the motor body. So it might not be a problem if I can get away with leaving it there and adjusting the position of the belt, but if I need to use any more of this slot which is still available, I'll probably have to remove a little bit of material here as well, which is not a big deal. I don't mind doing that. The other issue, which is in here, which I'll just show you now. It's not evident, but I'll move the bell out of the way and then pull it to one side so you can see. But our motor shaft isn't even coming through. In fact, it's about 5mm recessed into this original motor casing. Now I thought I'd have to make an extension anyway, because this pulley is also heavily recessed. It's like off a drill press as opposed to a milling machine, because you'd expect that to be sort of more, not necessarily solid, but have more support further up. So we'll have to make an extension, which it is what it is, and then that'll be it. The motor will be mounted, wire it up, should be ready to go. So we'll whip the motor off quickly. Maybe I'll machine that. Make the spindle extension for the pulley, and yeah, we're ready to go. Right then, I found a suitable bit of material. I always find that, especially in the home shop like this is, there's always a trade-off to be had between the ideal piece of material and something that you kind of want to use for that project, because you're very conscious that you don't want to use all your good bits for stuff like this, but that's exactly why you've got them. So I managed to find a bit of X-bar. I'm not quite sure what grade it is. Steel, obviously. Be ideal for this. Doesn't need to be anything special. So what we're going to do is going to throw this in 3-jaw while I've got it in. We'll center drill it, draw it out of the chuck then, and we'll be able to turn sort of both sections at the same time. So I'll be able to drill and obviously, I don't know, I've got a reamer, but be able to drill and size, say, the motor end and cut the other end at the same time, and then maybe even if we're lucky we might be able to part it off and we won't have to do anything else to it then. So we'll throw that in, center drill it, draw it out, and then hopefully get it all in one go, because it's just a bit longer than we need. It's about 5 inches and I need something about 4, so yeah, we'll see. Okay, so I did manage to get through that with a parting tool, but technology seems to evade me sometimes. So what I've gone and done is, obviously you saw me drill that, you didn't see me finish parting it off. But that's a nice fit on there. The pulley is a nice fit on there. So that should work all right. Tighten that down. I would have liked to fit the key, but I don't have any key cutting materials on. I know I could do it on a lathe. I'd rather not. I'd rather not abuse it. And then the pulley will fit on there. Only issue I might have is, although it is a good fit, I put a little dimple in so that the little grub screw will have something to bite onto. But I don't know if that's going to be good enough, especially with the heavier cuts. I might have to sort of drill and tap that, because again, I would like to put a key on, but guess what? I don't have a mill yet. And I can't manufacture that with the mill because obviously I need it for the motor. So I'm sort of catch-22 here. I need to have something that will key that pulley to the motor shaft. But yeah, probably just drill and tap and obviously bolt it with a longer grub screw or something. Otherwise, I maybe could grind a slot in and fit a bit of a bodge of a key. But again, I don't really want to do that. So that's what's left to do now, and then we'll be able to mount it onto the mill and probably get it working. Right, so that's the motor on. It's just out of shop, but it is fitted, and we've got a good range of movement now so that we can properly tension the belt and detension to move it up and down the pulleys as we like. So everything's clamped up. I've tightened everything up now. I can report that it all runs fine, great, no issues. The only sort of caveat with this, and it's quite a clever head to be honest, they call it an epicyclic head, and there's a planetary gear system in here, so that the sort of the high and the low speed is controlled by this little lever. Nice thing about it is you can do it while it's spinning. In fact, the instructions actually recommend that you change the ratios while it's spinning. The only problem with that is it's quite noisy, and it is documented, it is quite a noisy drive, but yeah, again, we compromise a bit of noise for such a versatile machine given the price. Now what we're going to do is we'll fire it up, we'll get it running, and we'll see how it cuts on some scrap steel. We can change the speed of this lever. That's slightly higher speed, so that's quieting down a little bit because it's not using the epicyclic gearbox as such anymore. Knock it up into low speed, but that's a lot noisy now because it's using that gear set. So we're not doing anything crazy, we're just going to run up and down this. Now I haven't squared anything, nothing's level, the head's not set. Obviously we'll have to trim it all in when we're ready. Well, this table needs a good clean first of all. I'll get the vice off and give it a nice once over, but we can address that in a later episode. So we'll just run a bit of a cut, we'll try and find the highest point, or the point closest to the cutter, and do a small cut. Right, so there we have it. I think you'll all agree that's a pretty decent finish considering. 0.3 cut that way first, and then took a 0.4 climb mill on the way back. And for a sort of a semi-rigid machine, or you'd expect a turret mill, definitely. Finish, not bad at all. You can see where I've stopped maybe a few places and changed the kind of the speed of the feed. Can't really avoid that on hand-powered machines. One thing I would like to do maybe in the future is put power feed on. That'd be lovely, but we'll see. Maybe I can sort of modify something, or definitely for the X-axis. Not so bothered about the other two. X, most common, obviously nice to have power feed on there, but yeah, overall, pretty pleased with that. Performance-wise, apart from the noise, which kind of expected with it having this epicyclic gear train, not bad at all. Okay, so quick summary. I won't keep you much longer. I can see a few at the back starting to leave. So, would I have one of these machines myself? Well, obviously I've got one, but would I recommend one? Absolutely. I mean, value for money wise, and the specifications of these machines make them really, really very good for the home shop. So it stands at a height of about 6'7", 6'8" with the motor on. Mine's a little bit higher because I've got a bigger specification motor on. But in terms of sort of compactness, it's pretty small. It's a lot smaller than the other turret mills that you can go for. Other specifications, well, the table's about 3.5 foot long with a total X travel of 23 inches. So it's got quite a good range of movement. Y's 9 inches and Z's 17 inches. So there's really is a vast amount of movement considering its relatively small size. Plus there's the 4 inches of the quill feed as well, which you've got at your disposal. And then that's without even talking about all the different and weird and wonderful positions you can put the turret in. Now, I do strongly recommend that you go and have a look at the website that this is featured on, because I probably can't demonstrate as well as that as what this mill can do. It is quite a heavy lump. I think it's about 850 kilos, so it's not in the same league as your Tom Seniors and your little Centex and things like that, but it does do a better job of sort of milling in general. So am I happy with it? Well, I'd give it a solid 7 out of 10. Obviously it does lack features, and I've mentioned them. The power feed is a big one. And on the Mark IIs, because this is a Mark 1, the Mark IIs do have power quill as well, which is obviously for drilling and general machining's quite useful to have. But overall, yeah, pretty happy with it, and absolutely I would recommend one if you can get one at the right price, because I wouldn't be looking at spending £700, £800, £1,000 on one of these mills, because you can just get so much better kit for that money at the minute. Well, anyway, I hope you enjoyed that. Thanks for watching from Yorkshire Fab Shop. I'll see you next time.